On this next example, we're going to write an equation given the intercepts. Now, what you're going to do here is you're going to use the linear factors given by the intercepts. And I'm talking about the x-intercepts. And then just like I did on the previous problem where I picked a point, here they're giving me the y-intercept to find A. And that'll make a lot more sense when I actually show you an example problem. So here we have write the equation of the quadratic with intercepts -2, 0, 3, 0, and 0, 1. So these are our x-intercepts, and this is your y-intercept. And if you put those on the graph, you'll notice that you've got -2, 0, we've got 3, 0, and we've got 0, 1. So our parabola is going to do something like this. So what that should tell you is that your A is going to be negative because it's flipped upside down. So if you work this out and get a positive A, you did something wrong. So let's start with our linear factors. We're going to write those from your x-intercepts. So if I have -2, 0, that means x equals -2. To write that as a factor, you're going to add the 2 back to the other side to get it set equal to 0, which will give you x plus 2 equals 0. X plus 2 is the linear factor. So basically you're just changing the sign because you're moving it to the other side. So the other one, I would have x equals 3. As a factor, that would be x minus 3 equals 0. So what that tells me is I've got some equation multiplied by a to tell me how thin or wide my parabola is, but then it's multiplied by x plus 2, x minus 3, my two linear factors. And I'm going to use my y-intercept to find my a. Just like before, this is x, this is y, so I'm going to set f of x equal to 1, because that's what y equals, a, and then I'm going to plug in 0 everywhere there's an x. So I've got 1 equals a times 2 times a -3, so 1 equals -6a, and then I'm going to divide by -6. So a equals -1/6. Now it just says write the equation. It doesn't tell you what form. So we can actually use this form of the equation and leave it like that just by plugging a in. So we can leave it as f of x equals -1/6 times your linear factors. You can FOIL that out and multiply through if you would like, but that answer is acceptable. Okay, our last example in this section is to find values of b and c so that this equation is true for the given vertex. Now, if you follow the videos that go along with your homework, they show you a different method. So if you want to look at that, you can. I'm going to show it to you slightly different. It gives us our vertex, and we know what A is. So I think the easiest way to do this is to actually use the vertex form, or your standard form, and plug in everything they give you. So they gave us A with that first part of the equation, and they gave us the vertex, so I'm going to have x minus 6 squared plus 1. And then if you just multiply that out and distribute, it will give you the equation in general form, the ax squared plus bx plus c. So just be careful here. We have to FOIL this first. So you've got x minus 6 times x minus 6. Do not distribute the 10 first, because remember your order of operations, you have to take care of the exponent before you can multiply. So when you FOIL, you get x squared minus 6x minus 6x plus 36. So that'll be x squared minus 12x plus 36. So I still have the 10 out here in front, times x squared minus 12x plus 36 plus 1. So now you can distribute the 10x squared minus 120x plus 360 plus the 1, and then combine like terms. And now you have your form in general form, and the negative 120 is your B, and the positive 361 is your C. And like I said, the homework videos show a slightly different method, and it's fine either way you want to look at it. You can use that method or my method. You will get the same answer.